Sorry about that.
Thank you. Sorry, my bad. So yeah, this is Intro to Python. My name is Yoon Ko. I'm a PhD working in Department of Computational Medicine. And here are the works of goals and outcomes. The goals are acquiring the most essential skills for solving computational problems and obtaining the basic expertise for computer programming and understanding the common pitfalls during professional programming and ways to overcome them. So expected outcome is that after the workshop, you will be familiar with the craft of creating software, and you will know the basic Python syntax and key programming constructs that fit to the majority of programming languages. You will learn basic algorithmic principles and data structures, and you will be aware of using libraries that already contain the absolute majority of coding components that your project may require. So what I want you to do is not just learning Python, but learn how to code. It is important to know that programming skills are more about the right way of structuring your program than just knowing about the syntax of the programming language. So once you gain programming skills in Python, you can easily switch to any other languages like R, C, Julia. There are many languages out there. And your understanding of algorithms and data structures is more valuable than your programming skills. Because those big tech companies will ask problems more about algorithms and data structures than about programming language syntaxes. And this course is about getting you started programming and showing you directions for your professor growth after this workshop. So why is it good to start with Python? There are many other factors. It is easy to learn and use, and it is quick to write simple codes. And it is a great fit for people who are not dedicated software engineers. So, you don't have to be experts to use Python. So it is ideal for who work with Excel, CSV files, or PDF files, and many other files. So, and it makes life of scientists, engineers, and other specialists easier. And many software engineers are working on Python, so there are many useful tools out there in Python already. And it is ideal for automating boring and repetitive tasks such as copy and editing files and folders around, sending files to servers, running software, and analyzing the results. So I'm a PhD in statistics, and you might know that the most used language there is R. But many of the aspects of Python is useful for computation in statistics, such as high performance computing, or so sometimes machine learning these days. Many of the packages are in Python, but not in R. So even the statisticians with domain-specific language still sometimes have to use Python for many computing tasks. So yeah, I don't classify myself as computer scientist, but rather computational scientist. But this mindset about how to think like a computer scientist is pretty useful. So you will give some kind of input to the program, and there will be some machine you might want to build. That is the task of programming. And after running your program, you will have some outputs you desire. So everything starts with a program formulation that consists of inputs and outputs. So one example could be an array of integers as an input, and the output might be the sum of the integers in the array. And how to solve this problem would be, what do we need to do to get the input, to get the desired output? Algorithms would be a list of instructions to get the output, and data structures would be how we conveniently represent the data that we are using, and how do we efficiently use this data. So for this problem, it would be rather simple. We will start with an array containing 1, 2, 3, 4, 5, and we start with 0 here. And for each value in this array, we add that value to this S. Then we will get the result of 15, 1 plus 2 plus 3 plus 4 plus 5. That is a basic loop structure of Python. We will get there later in this workshop. But this is a simple example of a Python program and how the algorithms work in general. So here's the outline of this workshop. Day 1, we will learn how to get started at first, and we will learn about basic data types and variables. So what kind of data we might have in computer programs? Something like text, some numbers, and some kind of even complex numbers, and those kind of things. And we have seen an array up here. We will learn about those and how to use them in program, and how to control the flow of program using some decision-making procedure. So if this value is greater than like 3, then we go to that code, and if not, we go to the other code. That kind of thing will be done today. Day 2, we'll be repeating code in loops. So this kind of for statement will be covered day 2, and we will talk about lists and how to read or write files. Day 3, we will formally define functions, how to reuse your code, and we will deal with some more data structures in sets and dictionaries, and cover how to use libraries and use many useful functions out there already made by other people. And if you are taking this workshop for UCLA credits, like, what was it, Bioinfo 275 or undergraduate research prep 199 and 99, the final homeworks and final quiz are required. And for those who are not taking this for UCLA credits, it is still recommended to cover this task. Some of the exercise ideas are partially borrowed from Zingaro's Python book and Chuan's at NTU, and many of the materials here are borrowed from Dr. Sergey Knizev, who previously run this workshop last academic year. Any questions so far? Then let's move on to how to get started. So in the email I sent around, I asked you to install Anaconda. And here is how to run your local installation of Python for this workshop. On Mac, open Spotlight Search, Command spacebar, and you can type in Anaconda Navigator. And open this thing. And you will see this window. And you will find Jupyter Notebook here. Press launch. And on your web browser, this interface will open. And then go to the file you have downloaded from the emails that I sent around earlier. .ipynb file. And you can open it. And that is how you open this material.
I don't know why, if we
Okay, let's see. Yeah, in case this is not very simple, we have a fallback plan. Let's go to Google's cloud using Google Colab. So open a web browser, and any web browser is okay, and log into your Google account. Then let's go to this web page, colab.research.google.com. Then you see this window with some help window if it is your first time here. And on upper right side, there is upload button. Click here and choose file and upload your notebook. Then you will be able to open it in this window. Then now you're running this Jupyter Notebook on Google's cloud, and you will be running Python that is installed in Google's machine. It is free, and it is quite useful for many tasks. And it even comes with a small GPU. So if you want to use it, it might be fine. Yeah.
file on Jupyter or yeah.
Let's see. Does anybody else having problems right now? Oh, all right.
It just says error.
It just says error. Then yeah, let's try sending around the file again. So in a notebook, you can write or edit cells of code, or write a cell with a text, or which is markdown formatted, which means mostly text. This is mostly text based with some marks up for for boldfaces or italics or those kind of things. And for markdown syntaxes, you can check this link. then you are running a Jupyter notebook now. And if it is running on Google's Colab, it is sometimes called Colab notebook. This is a open source tool for creating and sharing documents with Python code. So it contains live code and hypertext, which and this kind of approach is called literate programming. And there are similar applications in many other languages out there, like R, they have R Markdown Notebook, and in MATLAB, there is MATLAB Live Script. So you can run code in a cell using the run button or by pressing Shift Enter shortcut on the keyboard. And this is not the only way to run Python code. I wanted you to have the course material and the codes together. That is why I'm using Jupyter Notebook for this course. And the more basic way would be directly running Python code, and we will cover that on day 3. So let's get to your force programming. And it is common practice in many programming languages to start with a program that prints out hello world to your screen. It is a widely popular idiom for many starters, because it shows basic syntax of the language, and you can check if the system is set up properly. So what we will do is type and run the following code: print hello world in the code cell. So there are 2 types of cells here. One type is text cell, and the other is code cell. And code cells will have square brackets in front of it and have play button. So what I want you to do is type your code in this cell. And press this play button or press Shift Enter. Then you get an output. It prints hello world, so it is set up properly. So throughout this workshop, you will be asked to type in something to a code cell that is pre-built and execute it. And sometimes what to type in the code cell will be given directly, but I encourage you to type in the code yourself and get your hand dirty, because that is the more effective way to learn programming. So what is being done with this code? The function named print prints a string inside a parenthesis to your screen. This kind of function is a block of code which only runs when it is called, and you can pass data known as parameters or arguments into a function. We will learn how to use functions and how to write or define functions later in this workshop. And some of the features of one of the features in Python is comments, which is not interpreted by the Python interpreter. So let's again print anything here. And put some hash sign or pound sign and type in something. Anything after a hash sign will not be interpreted as a part of the program. So it will just print out hello world. So if you want some kind of comment in your code, this is how you do it. And another type of comment is done by multi-line string enclosed in triple quotation marks. Technically, this is how you define a string, but if it is not assigned to anything, it is just a comment. It is just defining as you just bring a string there and do nothing with it. So it is basically So it effectively works as a comment. So this is again just printing out hello world. Now let's get to variables and literals. Variables reserves a space in your computer memory to store some data, and it will have names to access the data. Variables can store many things in Python: strings, numbers, arrays, and many other types. Variables have its own name that allow access and modify the data, and literals represent exact values that can be stored in variables. An equal sign assigns values to a variable. So let's look at this line. My underscore variable, that is name of a variable, equals, inside double quotation marks, my first variable, exclamation point. With this line, what we are doing is defining a variable. So on the left side is a new variable name, my variable, and a line of text contained in a quotation marks. This defines a string to be stored to be used in a program. So by doing this, we are storing a data of text, my first variable, in a variable named my variable. You can use this string anywhere in the program using the name my variable. So what you can do is type in this code cell. And print my variable. Then you will see the text data saved to the variable being printed out. So you can also directly use literals anywhere in your program and use variables anywhere in your program. However, it is often more convenient to use variables for more sophisticated programs. So if the data is a like 5-line text, it would be much simpler to be given a nickname like this and print it out. Any questions so far? Mhm. So, sorry?
Are brackets
Mhm.
and parentheses interchangeable?
Oh,
So like when storing,
Mm. storing arrays and vice versa.
you can use either a bracket or a parentheses.
Actually, square brackets and
Yeah,
the circular bracket, you mean?
yeah.
They mean different thing in Python.
Oh.
Yeah.
So when do you use one?
So if you are using a function, you will always use this circular bracket, and the square bracket is for it is open for lists. We will talk about it later. So the the circular brackets and square brackets are not interchangeable. Let's talk about types of Python. Each variable and literal has a type. It can be checked with the function type. So by writing type and then inside a parenthesis giving a literal or variable, you will see type of each variable or literal. So if you type my variable here, because we define my variable here, it is a data of text. It is called string, and in Python, it is represented by str. And for just value 300, it is a whole number or integer. So it will give you int, short for integer. But if it is 300.0, it gives you a floating point number. So the result you get is float. By the way, what is being printed out is the last line. By the way, what is printed out here is the last line of the code. The result of the last line of the code, unless you directly use the print function. If the last line of the cell assigns something, nothing is displayed right here. So if you put all 3 lines here in a one cell, you will just see float. So if you want results from these lines, you will need to surround it with the print function. Then you see these kind of thing. So what is represented by the print function and what is shown as a result of code is sometimes different. But what we are talking about is basic data types in Python. For text data type, it is string str, and for numeric types, integer, floating point numbers, and complex numbers. For sequence types, we have list, tuple, and range. And for mapping type, it has several keys to obtain some of the values. It is a dictionary, DICT, and it can be true, and it can have true or false values. It is called Boolean type, and it is represented by four letter BOL, bool. And we will deal with some of these data types. First data type we will cover is string. It is a Python representation of text information. As we have seen before, string letters are surrounded by either a pair of single quotation marks or a pair of double quotation marks. But you cannot start a string with a single quotation mark and end a string with double quotation mark. So hello in double quotation mark and hello in single quotation marks, they are the same. But this will give you an error because you started a string with double quotation mark, but it never sees the closing double quotation mark. And there are special characters that can be used in the string. You can type \n to see a new line, \t to represent a text character, like typing the tab key in a text editor. And if you need a quotation mark of the same type as the including ones inside a string, it should be escaped using a backslash. Like this \t, backslash quotation mark. You can read more about escape character in this Wikipedia page. Let's have a short exercise. Replace this X and this Y with the word whatever you like, and try to run these following code.
Maybe it's the wiki page for the escape characters, but can you explain a little bit more? Like how, I just don't get how it's fixing the error when there's 3 quotation marks. Why are there 3 quotation marks?
Oh, this one?
Like in the exercise you gave us.
Oh, okay. Then yeah. Let's do it after you try something.
Okay.
I want you to get your hand dirty a little bit.
The backslash allows you to use characters in emoji. So
Yeah,
quote,
yeah.
allows you to put a quote in the middle of the string.
Yeah, backslash is for yeah, it is the characters that are not normally input by your keyboard, or sometimes sometimes the character that has better function.
So is it, I guess, my question, what characters specifically have to be specified using the backslash first? So for example, Python seems to be able to handle a comma in the middle of the string, but it can't handle a quote in the middle of the string.
Yeah, quotes. So quotes will have issues, so they will need to be asked. They will need to be escaped, and so to input a new line, it is \n, and to input a type character is \t, and for now that would be enough. But let's see if there is anything else worth mentioning. Yeah, backslash, of course.
Okay.
Yes, so yeah. And backspace, some octal value, some hex value. Yeah. Those are pretty much it that you will use in Python. All right. Have you tried these ones?
Sure, so the backslash, whatever quotation you want to do, that just tells it to print the quotation without it freaking out and expecting the second part of it.
Yeah, that's right. So without backslash, it just thinks this one as a closing.
Yeah, like
Quotation
an actual
marks there.
functional quotation.
Yeah,
Okay.
and we want to escape from that by using backslash there.
Okay.
If you run this one. It will stop here because of the error, and you can escape it with the backslash. And this one is again raising error. You can escape it with backslash again. And what you can also do is just using the other type of quotation mark outside, then you don't need to escape with using a backslash. And this one is escaping a backslash to input a backslash. So let's try to fix the errors in this one. How would you do it? Say you have something like this. And what you would do is insert a backslash here to escape it and print out hi mom like this. And for the second line, it will be like this. And print it to print it as a whole line, you need to escape this one with a backslash. But you don't have to escape it with backslash. Good, because double quotation mark is defining the string. Now let's get to some of the string operations and methods. The strings can be concatenated by using the plus sign. So typing hello, then plus sign, and another string literal. Then it will put those two strings together. And another concept of string is method. So strings will have these methods to operate on the data. So a method looks like a function, but it is dedicated to data of specific type. In this case, it is dedicated to an empty string. So the join method of an empty string is called to concatenate the strings in a list like this, delimited by an empty string. So it is just joined together. The square brackets here define a list. So items listed in a pair of square brackets is a list. We will get to it tomorrow. So by doing this, we have hello world again. And you can also format a string by replacing curly brackets with a value using a arguments of the format method. So this line with these curly brackets, this is a string with 3 pairs of curly brackets, and the format methods replaces the curly brackets with the values inside the given as parameters. So the first pair of curly brackets will be replaced by the value 2, second one by 2 again, and third one the result of 2 plus 2. So what we get is 2 plus 2 equals 4. And with this line, that this means keyworded value inside a format. So it will give you value of 2 in 2 decimal points of floating point number. So the result is discount colon and then $sign, then 2 plus 0, 0, because it is defined by this points to F. And white spaces at the beginning or end of the string can be removed by using the strip method. So running this code, ASCII dot strip. With this, the spaces before and after the main part is removed. And you can also count the number of occurrences of a substring using the count method. So this code will count the number of occurrences of AS. So by running this, you will get the number 3 because AS appears in this string 3 times. Time for another exercise. Read and print these variables with x, y, z, x1 and y1 replaced with a word of your choice. And then you try to use the strip method on them and save them as S3 and S4. And then count the number of spaces in S1 and S3 using the dot count method. And then concatenate S1 and S2 then print it. And concatenate S3 and S4 then print it. So first part was creating and printing the variables. So S1 equals \t hi-ho hey \n. S2 will be \n who whatever \n. Now we defined 2 strings. And let's strip the white spaces before and after each of the string. So S3, we will do S1 dot strip. And let's see the result. It removes all the white spaces at the beginning and end of the string. So it removes both \t, the typed character, and space, and space and \n, the new line character at the end. So they are all removed. If we do the same thing with S2, I'll add a new code cell down here. We see again all the preceding white space characters. New line is a white space. Type character is white space, so they are removed. New line space, new line space, they are all removed, and space and new line, they are also removed. So it is just \hu at the end. So let's count the number of spaces using the count method in S1 and S3. S1 dot count space character. We have 4 of them. 1, 2, 3, 4. And for S3, we have 2 of them because it is high overhead and nothing else outside. And for concatenating two variables, S1 and S2, this should work. And some of you tried using the join method. How to use it is begin with a string and then join, and inside the square brackets, putting in the variables S1, comma, and then S2. And then what is used as a delimiter is the string coming before the join. So if we had something else here, like 0, then it would have been S1 followed by a 0 and then S2. So it is what is in this string defining the output of this join method. Yes.
Could you do that one more time?
So we have been using an empty string before the join method. We can put something else inside here. Then whatever here will be used as a delimiter. So S1 here, S2 here, joined by a 0. Yeah, so you can also use a new line character here. Then it will be it will have another new line character there. So a new line will be added between these two strings. Like this. And S3 and S4 concatenation, it is like this. It is just Iohe and Hehu and without any delimiters, so it is just like this. And if you tried something like space dot join S3 and S4, it will be joined by a space, so it will be something like this. Time for a break. We will return 10:27. So let's talk about how the numeric values in Python is stored. There are 3 types of numbers in Python: integers, floating point numbers, and complex numbers. Integers are for whole numbers and represented in an obvious way. You type this one, you have defined an integer. The type of x is integer. And floating point numbers are for real values, they are not integers. So this is a way of defining a floating number. And z equals 5e minus 6. This is another. And this means 5 times 10 to the power of minus 6. Then for complex numbers, the character J is used for imaginary unit, square root of -1. So 0.3 plus 7.1j. This is a way of representing a complex number. We will mainly deal with integers and floating point numbers in this workshop. And there are many obvious operations for the numeric data here. Plus, minus sign. Of course, they add and subtract the numbers. So 5 plus 7, what is it? Oh, of course. And then 5 minus 7. That will give you minus 2. And asterisk define multiplication. So it is 5 times 7, it is 35. And double asterisk define exponentiation. So 2 asterisk 5 is 2 to the power of 5, and it is 32. And of course, circular brackets will define the priority between the operators. So this will be 12 times 12. 5 plus 7 is computed first. And without it, operators have priority, and multiplication has higher priority compared to plus and minus. So it will be 5 plus 7 times 12. So it is 89. 7 times 12 is 84 plus 5. It is 89. And there are two kinds of divisions in Python. Single slash and double slash. Double slash defines an integer division or quotient. So it is basically a floor function of division. Floor function means the highest integer not exceeding a certain value. So integer division between integers give another integer. So 5 integer division 3, quotient is 1 and the remainder is 2. So it will give you 1. And the modulo operation is defined by this percent sign, and it gives you a remainder of a division. Remainder is an integer, so 5% sign, then 3, it will give you 2. And with a single slash, it gives you numeric division. So it is mathematical division, and the result will be in floating point number, even if it is between the integers. So it does not result in integer, so it will give you 1.666667. The different languages have different rules for these kind of divisions, so you have to be careful sometimes. So for language like C, 5 divided by 3, it will give you just an integer, 1. Just a quotient. So you have to be careful about these kind of stuff. Time for a 1-minute exercise. Run this code. And see what is being printed out. So what is printed out? It is 5. Why did not x change? Because we added 5 to x, but we didn't save it anywhere. So it is just gone. You gotta assign this result to anywhere else to reuse it. And you can even reassign a variable using existing value like this, x equals x plus 5. That will add 5 to x, and this line will print out 10. And there is another operator, plus then equal sign. It is for adding and reassign. So if we do this, 5 will be added to x again, so it will print out 15. There are similar operators for subtraction, multiplication, and division. And of course, there is something like this for integer division. Now let's try this. So right now, the type of x is integer. And let's try adding 0.0 to it. Then the type has changed to float. What happens to x? When did this happen? Because integer x is added by 0.0, a floating point number. And when different types of numbers are operated together like this, when integer is added by a floating point number, the result is the more general type. And in this case, more general type is floating point number. So the result is floating point number. So that is why x became a floating point number. It is automatically coerced. Let's have a quick pop-up quiz. What is the output of this code? 5. Yes, it is 5. Because we do add 11 to z, but we don't save anything. Then how about this one? Answer is 52. Is it? Let's see. So x is 41. We store x plus 11 to z. That is 52. Now x is 80. But we didn't update z, so z is still 52. So we're assigning x doesn't automatically update this z defined here. So the result is 52. Let's have another exercise. compute the volume of volume and surface area of a sphere with radius 6. Here are the formula. The volume of a sphere is 4/3 times pi times radius cubed, and area 4 times pi times r squared, where r is the radius. Oh, we didn't give value of pi here. Yeah, let's define pi like this. How do you
I like if I wanted to like. 1, 2, 2, and then afterwards. All over and then the. And this is.
you don't use that operator instead? You just do this.
Oh, so you can't do the reassignment.
Not really.
No, thank you.
Are you guys done with this one? Not yet? All right. Are you guys done? All right, let's do it. So the volume is 4/3 times pi times r is 6, and then r to the power of 3. That will be the volume. It is capital V. And the area is 4 times pi times r squared. See. So Jalen is asking my cell is running nonstop. Maybe user error. Is it a loop you are running? Jalen?
No. Well, now that I'm seeing how you break it down, I think it was just user error. I tried to like do the calculations and then like on my own and then just put the whole thing and run it. But I see that you have to define pi r, and then I also was having trouble with how to do like to the power of. So I see that it's a double asterisk. So I'm redoing it now.
Is it still running, or were we able to?
I was able to fix it. I'm sorry.
Oh, you were able to fix it? Okay. There is a way to stop a running cell if it is running indefinitely. There is a stop button and up here in Jupyter Notebook. And Coca-Cola will also have that kind of thing. And we will talk about it tomorrow when we intentionally do some infinite loops. Let's move on to casting. Sometimes you may need to convert values between types. For example, it is impossible to concatenate a string with a number with a plus sign. So if you write this kind of thing, discount colon $sign and then +2, then it is an error. You can only concatenate string, not integer, to string. So what you have to do is change the type of the number 2 to string, which is casting. And to do so, there is a function named str to do so. Discount colon $sign and then plus string representation of 2. And then you get this one. Let's do similar with floating point type. Create one variable of string type and one variable of floating type and try to concatenate them with your variables. I'll give you 2 minutes for this. So it will be simple. String, let's just do discount colon and $sign again. And for a floating point value, let's do 3.0. Then how do we concatenate these? S plus F. Then it will fail. Because F is in floating point number and S is in string, so we have to cast the floating point number to string. Then we get discount equals $sign, then 3.0. By the way, the floating point numbers have limited number of significant bits in its representation. So 0.2 plus 0.1 will give you something like this. And at the end, you will see some strange number at the end. It is the limitation of the floating point representation of a number. So how the numbers are represented in computer for the floating point numbers, it is similar to how you would write floating point numbers in decimal place, like this. So in scientific notation, 7.652 times 10 to the power of 3 is 7,652 in the form of scientific notation, right? And computer saves mantissa and exponent in the binary form. So 4.5 would be converted to 1.001 times 2 to the power of 2. Computer stores this part as mantissa, and this part as exponent.
What's the 0, 0, 1?
Oh, in binary notation.
Sorry, what did you call it though? The word that starts with an M?
Mantissa, Mantissa. So computer stores this part and this part, and this part has limited precision. So if we write these in decimal format, it is automatically converted to binary format. So and they added them in binary form, then converted back to decimal number. So that is where we get some marginal number from round off error.
So if you're doing something grossly precise, that
If
gonna
if that kind of thing is absolutely needed, like in fields of physics or that kind of thing, there is a packages for multiple precision, which stores more significant bit digits.
thank you.
So the round of error will be everywhere when you deal with numeric data. So how to deal with those propagation of round of errors? That is one of the key aspects of numerical analysis. It is in-depth story for this workshop. But there are studies of that. I will tell you. Let's deal with some interactive functionality of Python. Input is a function that reads data from user's input as a string. So if you type in input, opening parenthesis and then closing parenthesis, you will see a dialog like this. You can type in anything here. Then the result is a string. It doesn't? Oh. Let's see. Maybe it's older version of Jupyter Notebook or something. Yeah, I think it's version issue of Jupyter Notebook. And input can, of course, redirect user's input to variables. So you can save what you're typing like this. Then the string test is stored to the user input variable. And by using an argument or parameter to the input function, you can ask questions. So user move input, then how will reach there? Then you can type anything here. Then it will be stored to this one. Then let's try to read in some numbers. If you run this, you get an error. No, it is not an error, but it is 1, 2, 3, 4 repeated. Because you read it, because the computer reads it as an integer. No, reads it as a string, and 2 times a string is repeating a string twice. So what you get is 1, 2, 3, 4, 1, 2, 3, 4. And if you try to divide it by 2, then you get an error because you're trying to divide a string by a number, and that is not defined. So what to do if you use the data as an integer? You have to convert it to an integer by casting. And for integer, the casting function is int. So what you would do is this one. And by running this, the result is twice of the user input, so 2, 4, 6, 8. And now let's get to writing output. The print function can output variables of different types to display if they are given as separate parameters. So print2 prints out the value 2. And with this line, we are putting 5 different parameters to the print function. And one is integer, string, integer, string, and again integer. It can be mixed like this. If they are used as parameters for the print function. So this is printed out properly. And you can also use variables, of course. So a equals 2 times 2. And then you can print out 2 plus 2 equals, and then comma, and then variable a. Then you get the desired result. And as we discussed before, we can also use formatting and try this line. We have done this before. And floats and integers can be converted to string. And their string representation of type can be printed out like this. So a equals 2.5, and then as type of float, and then b is transformed into a string now, and b as type of string. Let's do an exercise. Write a program that reads user sentence and counts the number of words in the sentence and stores it as a variable and prints the number of words to the user. You can use input function, print function, and count method of string. So the exercise was to read user sentence and then count the number of words in the sentence and store as a variable and print the number of words to the user. So we can do this to get the user input. And then let's do a simple thing and just count the number of spaces. And then we can print. Like this. This will work, I think. Hello, my friend. And oh yeah, it just counts the spaces, so we have to add 1 to it. Then it is 3 words. And we have another exercise. This time we will read a radius of a sphere from the user and compute the volume and surface area of the sphere. We can reuse the code that we wrote before. let's get to it now. So I'm pasting the code that we used before. Then we will get a user input for the radius. And then print volume. And area. Then we would run. No, because R is input as a string, so we have to convert it to a floating point number with the method with the function float. And let's try it again. Now we get the results. And another quick exercise, converting Celsius to Fahrenheit convert. So yeah, people in US mainly use Fahrenheit, but many other places use Celsius, and we get lots of confusion from this every day. All right, are you done? So let's get C as a user input. And F is 9/5 times C plus 32.0. So 20 degrees Celsius is, all right, I forgot to print. is 68 in Fahrenheit. Later in this workshop, we will learn how to formally write this functionality as a function. Now it's time for another basic data type, Booleans, and logical expressions and getting decisions. Boolean is a separate data type for yes or no, or true or false. It's called. So the literals for defining these Boolean values are true and false, with capital T and capital F. So if you print type of true, you will see bool. And there are relational operations that return Booleans. So is x less than y using this inequality sign, and less than inequality and then equal sign asks, is x less than or equal to y? And with greater than inequality character, you can ask, is x greater than y? And greater than equal sign, it asks, is x greater than or equal to y? But we are using equal sign for assignment, so to check if it is equal, if x is equal to y, we use double equal signs. So x equals y asks, is x equal to y? And to ask if x is not equal to y, we use exclamation point and then equal sign. So this one is if 10 is less than 15, it is true. So the result is true. And this one asks if 12 is greater than 12. It is again, no, it is false. So it will give you false like this. But if you add an equal sign here, then it becomes true. Because you're asking if 12 is greater than or equal to 12. So it is true then. And then you can compare the strings with inequalities. And what it asks is, in alphabetical order, if AB comes after or is it same as BB. So this is false because AB comes earlier than BB in alphabetical order. Let's do a quick exercise. Create and initialize two variables of numerical type x and y, and create a variable b that is equal to x and some relational greater than y. And then print the variable b and print type of the variable b. One more minute. So what you could do is x equals, put some values to x, like 1.1, 1.2, and put another value to y. Let's try 3.7. And then you can define b as something like this. X greater than equal to y. Then print y, print b, and print type of b. Then what is printed is false, and then the class of bool, because 1.2 is not greater than or equal to 3.7. Then what is the output of this code? False. This false, because x is 12 and this is false, so it prints false. An important use of the Boolean type is control flow using the if statement. So if statement can alternate the program flow using Booleans. So if some statement is true, then this part here will run. And if there is an optional else block. If nothing is run above, then it will run the code here. And if you need multiple conditions to be checked, you can use else if. So if this is true, it runs it. Else if this is true, it runs this one. Otherwise, the last part will be run. And in Python, the code blocks for control flow or any other statements defined by these columns, the block inside it is defined by indentation rather than a set of brackets or AND keywords in other languages. So be careful with indentation levels. It is recommended to use 4 space indentation, and some code editors like this one will automatically do that for you. So let's try something like this. In a basketball game, Eagles got 90 points and Tigers got 97 points. And let's print out which team won. Eagles score is 90 and Tigers. Then if Eagles score, actually there is an automatic completion for collab, is greater than Tigers score. And then you have to put a colon here. Then, colon uses 2 spaces. Okay. If eagle's score is higher, then it will print out eagle's win. Like this. And because this is false, nothing is wrong. So how to see if tigers win? Let's try putting else statements and put this. Because tigers have higher score, this will be false, and this part will run. So we will see tigers win. Then let's modify this program a little bit to accept user input for eagle score and tiger score. What we do is simple. Int input input for tiger scores also. Now you can input eagle score and tiger score. Eagles 90, tigers 97, then tigers win. So we need to, let's check if it works well in all the cases we consider. It is a concept of unit tests. To maintain the quality of the code, each line of the program should work reliably without errors. So the concept of unit testing allows software developers to make sure that each part of the code is working correctly. So a set of trivial tests with known answers that allow to prove the correctness of the code is called a set of unit tests. We will not cover a formal way to do the unit tests, but let's try basic stuffs before finishing off this example. So you need to check with several of your inputs if the code works correctly. So does it work if the eagle score is 40 and tiger score is 40? No, because it goes to else block, it prints out tigers win. Then what should we do here?
To have any sequence statement.
Yes, we need to add another condition here using the else if statement. The keyword is ELIF, short for else if, and then if tigers total score is higher than eagle's total score, then you should put colon here again. Print tigers win. And otherwise it has to be tied, right? And you go to tiebreaker or something like that. So now we try 40-40 and we will get the message here. And if you put 74 for eagles and 94 tigers, it will go to this block and print out tigers win. And since indentations matter in Python, there is a keyword pass that does nothing in a code block. So in something like this, in this code, A equals 3 and B equals 3. If A is greater than B, it prints out A is greater. If they are the same, prints nothing with the pass keyword, and otherwise it will print out B is greater. And because A equals B, it prints out nothing. And if it were A was 3.1, it prints out A is greater. And if B is 3.2, then it prints out B is greater. Then let's go to another pop-up quiz. What does this program print?
Should pick one.
One? Any other answers? Who thinks it's 2? First, nobody? 3? 12? 17? All right. Let's see what is being printed out. It is 3. Why is it? Because it is A is 17 at first. And then in the first if block, A is greater than 12, so it runs this one. So A is now 1. And this one is a separate if block because its indentation is outside. And A is now less than or equal to 12, so A is now 3. And else block is skipped because this condition was met, so it prints out 3. And there are more Boolean operators, and, or, and not. These operate on 2 Boolean values in case of or and not. So if A is false, so A or B results in true if A is true or B is true, and A and B results in true if A is true and B is true. So it has intuitive meaning. And not A, which just inverts the value of the Boolean variable. So false becomes true, true becomes false. And because and is something like multiplication in Boolean logic, and or is something like addition in Boolean logic. So and has higher priority than or, and not has a higher priority than and. And of course, the priority can be changed using the parentheses. Here are the statements we will try. True and false. It is false. True or false? Is it true or false? It is true. True or true and false. Because and has higher priority, this is evaluated for first. That is false, and then true or this one. It is false, so it is still true. And it is same as this because and is higher priority. And if you do this, it is true and false, so it becomes false. And not true is false. And you can do with numerical comparisons. So this is false. And is 5 greater than 4 or 5 less than or equal to 4? This is invariably true. And in this case, it is true. This one is false because this is false and this is true. And this one not has higher priority, so it is false and false. So it is false. It is same as this one. And with parentheses, we can change the priority, not true and false, and it is not false, and that means true. Now let's get to an exercise. Let's write a program that checks if a number from a user's input is divisible by 3, 5, 7, but not by 15, 21, 35, or 105. Actually, we're running out of time, so let's do it now. So let's get the number first. And then if none is divisible by 3, this statement will be true, right? And we will check it with 5. Sorry. And check it with 7. And we will check it with 15, 21, 35, 105. Let's write all that first. And let's put relational operators and Boolean operators in here. Is that? So first condition we will check is the first part. Is it divisible by 3, 5, or 7? So we put parentheses here and or. And we put or here again. And what do we put what do we put here? Right, it is and not. So if either of these are true, it's gonna be true, but if this part is true, then it should be no. So what value should we try? 6. Then it is yes. 210. It is no, because it is divisible by 105.
So could you write that whole thing or like make this result the same if you changed and not to just and then exclamation equals for everything after? Like, is that equivalent?
This one?
No, just like, yeah, and then for the everything in the parentheses where you have a double equal sign.
Mhm.
You do the exclamation. Is that equivalent?
Actually,
You know what I mean?
yeah, I understand. It is the Morgan's law. You have to put and. You have to use and instead of or then. Because the number shouldn't be divisible by 15, shouldn't be divisible by 21, shouldn't be divisible by 35, shouldn't be divisible by 105. So it all becomes and condition. Let's try the final example of the day. Write a program that checks if the year from a user's input is a leap year. And to check that, you first divide the year by 4. If it is fully divisible by 4, it's a leap year. For example, year 2016 is divisible by 4, so it is a leap year. However, 2015 is not a leap year. However, century years like 300, 700, 1900, 2000, 2000, they need to be checked if they are divisible by 400 to check whether they are leap year or not. Century years not divisible by 400 is not a leap year, and century years divisible by 400 is a leap year. So year 2000 is a leap year, 1900 not a leap year. All right, let's try it. So let's get a user input for the year. And of course, let's put this condition. Then we will need to do something with this. Otherwise, it is not a leap year. Then what should we do with this one? We need to check if it is divisible by 400. No, 100, sorry. If it is not divisible by 100, it is a leap year. But if it is divisible by 100, what do we need to do? Check if it is divisible by 400. If it is divisible by 400, it is a leap year. And otherwise, it is not a leap year. And be careful of the indentation levels. Let's see if it is correct. So 2016, is it leap year? Yes. 2015, not a leap year. Year 900 or 1900, not a leap year. And year 2000 is a leap year. So you can freely use nested if statements if as long as you get indentation right. Here's an additional test, progressive income tax rate. We will start with this example tomorrow. And if you are taking this for UCLA grades, we got some problems for graded tests. I will give you more detailed direction to how to submit the graded tests later. But I can tell you this is from youth coding competition, and using what you have learned, you can solve these problems.
Can you go back up? Yeah,
This one,
yeah.
all right. So today you learned how to start Python and learned about basic data types of strings, numbers, and booleans, and how to use if statements. Tomorrow we will talk about loops and what else was there?
Can you sorry,
Sorry.
can you go back to the solution?
Yeah. So tomorrow we will get to loops and lists and reading writing box. I'll be back there. Where was it? All right. That is the session today. Thank you. Mhm. You can press backspace. It matters.
So this was working before, like in assigning whatever input to an entry, but now I get object is not callable.
Let's see. You have to look at that. It's, I think you should restart the session. I think you have will wrote something to this engineer keyword.
Okay, is it, can you just like walk me through this in human language, like?
Okay. I have a question. Hold on. Let me stop the recording first.